just making it possible now. Okay, we are live on YouTube. So again, good evening. Thank you for having finding time to be with us tonight. We have with us Blau from AndyMark. He's engineer, and he is very, very thrilled to be with you tonight to present you about the AndyMark's technical solutions for the FTC robots, and also to tell you about the way from the concept to the production for game elements that you are using for some years now. We are in the 5th season, so you've seen different materials, different ideas, and Danny, as being part of that team, can share with you many more information. So please assault him with questions. Questions will be here in the chat, so please, everybody who would like to address questions to Danny, to address them in the chat. And for the guys on the YouTube, I will watch the YouTube and I will paste the question here in the chat. So Danny, please enjoy. Good evening and thank you.
Thank you very much for having me. This is a wonderful opportunity. So I'm really excited to be here and be able to speak to everybody. So like Anna said, my name is Danny Blau. I am a product development engineer here at AndyMark. And let me just share my screen real quick. All right. So as I'm kind of going through the presentation, we'll sort of start with, sort of a brief introduction to AndyMark. We'll get into a little bit of the game design sort of process, and then kind of go to some more of the robot specific elements sort of in the second chunk. But please, if you have questions, feel free to drop those in the chat. Hoping to have a really sort of interactive, back and forth kind of a discussion here today. And so with that, we will continue. So introduction to AndyMark. So I started in the first LEGO League program back in 2002. I started with AndyMark in 2013. I've worked product development for AndyMark sort of the whole time here. And a little bit later on, I became the product line architect for all of our sort of FTC robot products. And I also sort of lead and manage the AndyMark side of the game development process. And so I'll touch a little bit more on that a little bit later. But I've been in FIRST for more than half my life. So that's kind of my cool fun fact for the day. And you can see there the contact information and the phone number if you ever want to get in touch with AndyMark. All right, so what is AndyMark? Well, actually a better question is, who is AndyMark? So AndyMark was founded by two gentlemen, Andy and Mark, engineers, not always the most creative. And so the company was founded back in 2004, specifically to make parts for teams in FIRST. This isn't some other, a business aimed at, industrial robotics or this or that. AndyMark was created specifically to help FIRST teams get parts that were sort of the right size and the right shape for the styles of things that they were doing. So Andy is still company president. Mark retired from his role back in 2016, and both started mentoring FIRST teams in the late 90s. All right, and so the AndyMark staff, largely made up of mentors, alumni, parents, volunteers, and sort of other members of the FIRST community. We range from about 25 to 40 people, depending on the time of year. So as you might imagine, during, sort of kickoff season, we have a lot more orders coming in. We have kind of a lot more stuff happening. And so, we really have to, sort of jump the number of people that we have working, especially out in sort of the warehouse doing pick and pack and those sort of things. Combined, we have more than 200 years of FIRST experience, and we have several half-lifers on staff. And I think that one of the things that the profile of our staff really points towards is AndyMark is really sort of a company, created and managed, by first people for first people. This is really a bunch of, us sort of living our passion, living our hobby, as a way to go do first. All right, so now what is AndyMark? AndyMark, our mission statement, AndyMark strives to develop innovative products and outstanding service while inspiring our customers and making a positive impact in our community. That is always the thing that, we sort of, come back, to, as we're trying to, move through the day. And so we make parts and components and assemblies for first teams and their robots. We're not just limited to the robots themselves. We have things like, battery chargers and tools and fields and kits and carrying bags and all that kind of stuff. So we really try to go beyond just the things for the robot and sort of things for, the team to sort of function as a whole. Sometimes, we design those parts ourselves, and sometimes we source them from, existing vendors and existing suppliers. All right, so where are we located? We are in Kokomo, Indiana, just a short 8,399 kilometers from Bucharest. We do some manufacturing in-house here at our facility. We do sort of a good, chunk of our manufacturing here in town, at various other, vendors and suppliers that we have. Throughout most of the Midwest is sort of where we get the rest of our manufacturing. And we do all of our order fulfillment through our headquarters here in Kokomo. So all of our picking and packing, all of that stuff happens here. And for certain regions of the world, we actually do get a little bit of help on some of that order fulfillment, where we can, ship over, one big pile of, one big shipment, to a central spot in Romania, and then have it sort of, get distributed from there. Or, sometimes, organizations, will put in big orders and help things get distributed that way. So, we really try to leverage, those partnerships and those alliances, as best we can, to help make sure that the experience for all of you is as best as it can be. All right, so our history with FTC started back in 2012, where we sort of started distributing the game pieces for FTC. And then in 2014, that sort of took the next step forward, where we started doing more than just the game piece by itself and really started to do the entirety of, the field for the FTC program. And so that started with the game called Cascade Effect, pictured down on the screen there. And we some of the early products that we also carried were things like the soft tile, the field perimeter, and the Samantha module, which actually was a communications device to help the robots talk back to the drivers. But that was like 3 or 4 control system iterations ago. So, but that was a part that, we helped do the order fulfillment for first. So now kind of moving forward into how the game each year gets developed. And so this is where, I got to stop for a quick second and kind of talk about the people that are involved at this point. So there is a game design committee, which is a group of volunteers that first is put together. And sort of they're the ones that are going through and sort of putting the real concept together. So this year it was all about throwing rings and kind of playing, frisbee catch with the robot. And so that game concept and a lot of the decision making that, kind of flows from that all comes from the game design committee. Also involved is FIRST itself. And so they are, kind of walking along with us, step for step, making sure that we're on the right pathway and we're moving in the right directions. And so they're the ones that, get, the final sign off on, sort of all the components to make sure that, they're going to be robust enough and they're going to be sort of the right quality. And then there's AndyMark. And so we're working with the game design committee and FIRST sort of on a very routine weekly basis as we go through the game design process, from the start of this process to kickoff is about a year, sometimes a little bit more than a year. So you can kind of see some of the early concepts for what would become ultimate goal, on the screen here. And so those concepts started in August of 2019. So that was even a full month before the kickoff for Skystone. So right around the time that the prior year is getting kicked off to the world, behind the scenes, we are starting to work on the next game. And the reason we need such a long runway is because we have so many different parts and components to, design, concept, test, prototype, and then really one of the biggest chunks of time is manufacturing. And so giving ourselves enough runway so that we can get through all of that manufacturing, and really have sort of a good quality, product at the end there. So you can kind of see in some of these, concepts here, the game had some of the hallmarks, that are in, what got, released back in September. The goals are sort of on one end of the field. The robots are driving around. They're shooting various, game piece, sort of things. And we've kind of got a number of different, things happening there. But, really, these are really, really rough. At one point, the picture on the lower side there, excuse me, was sort of more of a tic-tac-toe theme, sort of variation on the game where, robots would have different ability to score in different locations, and sort of get bonuses based on, if they sort of owned all three goals in a row. And so, some different gameplay methodologies, sort of at work on that one. And then the one on the upper corner, we sort of had the old relics, sort of as a stand-in there. But a thought there might have been that the Red Alliance may get to place their defenders, their blockers, in front of the Blue Alliance goal, and vice versa. And so that could be sort of an interesting gameplay, thing of before the match starts. Alliances are out there putting their defenders, their blockers, out in front of goals for the other side. So how would that sort of work out? So kind of really at this early phase, we have a little bit of the idea, but we're trying to explore different ways that the gameplay can kind of work. And then we start getting through some of those evolutions, and start trying to think of like what are some different ways that we could play this game. And so we have some different components kind of come into the field here, from almost like a skee ball style ramp, the big orange item there, a ramp that you could either, sort of roll on their edge or sort of maybe skip like a stone, game pieces, up those ramps and various things. Just again, kind of playing with more different variations on the concept. We also talked about maybe adding a platform and a limbo bar. The limbo bar would have been somewhat reminiscent of what was on the field last year for Skystone, and helping robots sort of figure out where they need to shoot from, and sort of maybe putting some barriers in place there to do some of those sort of things. So looking at different concepts like that. And also then we had the one in the bottom corner where we're like, well, if we turn the goals sideways and you actually have to take maybe more of an odd angle sort of shot, or even see if we can get the game pieces to curl, that might be another way to sort of change up some of the dynamics of the game. I just want to see. Okay. And so at this point, we're sort of looking at the September to October timeframe, where we're starting to do a little bit of evolution, a little bit of refinement on the field elements here. And we're kind of, walking through some of those things. And then late October 2019 is sort of the first time that our working model for the game field started to look like the thing that it would be at the end. Now, we didn't know this at the time, but it's kind of fun to go backwards and say, what's the earliest point that it really sort of looked like that thing that we did in the end? And so for this game, for this cycle, late October was sort of when we got to that point where it really kind of started to look like what our finished product was going to be. And so at that point, we didn't know exactly how much netting we were going to need in order to be safe. So that these, what happens if a robot shoots a game piece, in a weird direction, off towards the human players. And so we hadn't yet sort of settled in on what the game piece was going to be exactly. So we didn't know how much it was going to hurt. But the tower goals really sort of look like, pretty close to how they were going to function sort of in the end. And then the central field element, this is very close in functionality to what it was going to be like in the end. We have these same little targets, these same paddles, that robots were going to try to, throw game pieces at to knock over. All right, so at that point, we kind of got some of the full field, to a spot, and we kind of started to dive into the details November and December. And so we were playing around with some of the different concepts for, what the wobble goals should be. That was something that was in the gameplay from fairly early on, was having these extra sort of, goals on the field. And so what should those look like? And so as we were going through this process, we were looking at, different sizes, should an extra game piece be able to fit on, next to the pole, or do we want something like that? We even talked about a smaller version where a game piece would not fit next to the pole. It would fall off. So again, playing with different things. And then also sort of around this time is when we started working on some prototypes. So this is a 3D printed version of one of the wobble goal bases that we have up here, and we were playing with adding some weights. You can kind of see that, I hope. Adding some weights to the bottom of this so that help weigh it down and help it come back to sitting upright. And so this one is another print. We have a little bit of a ding here. So as much we can, we try to do some real practical sort of testing, with the prototypes. We take robots, we drive them into things, we bash them around, we bang them up, trying to get them to really replicate what we think robots are going to do when they're playing the game, and make sure that our components are going to kind of live up to that. And so again, this whole time, that we're going through all this process, we're meeting with the game design committee. They're the ones that are telling us, we want a little bit more in this direction, we want a little bit more in that direction. And then, we sort of take that as our homework, until we meet with them the next time and try to, make some progress and further, that thing and get ready for, some of those production deadlines. So the tower goal went through, some various stages of evolution. The game design committee knew that they wanted the high goal to be, harder still, compared to the middle goal. And so playing with different concepts, is it, it's up high, but it's also smaller, and, does if you miss to the left or to the right, does that score for the opposite alliance? That having each tower be a goal for multiple, for both different alliances was part of the game from very early on. So that was something that, people were fairly excited about. And so we were kind of going through some of these early, renditions. We're kind of going through, not only different sort of like concepts, but also different manufacturing methodologies. So from more like flat goods, on some of the early prototype or early ideas, to some of the net and pipe work, towards the, on the second prototype, and then, over to a formed sort of basin part, that we could do in multiple colors, that could sort of, use several of those with a framework around it, to sort of be another third variation on another different manufacturing method. One thing that we knew from fairly early on, from first, was sort of the theme around the game, the game changers theme. And so having something that sort of looked like a sports net, a sports goal, was something that, they were fairly excited about. And so we started to, sort of work the tower sort of in that direction. And, this is sort of when the backboard, kind of came into play. At that point, sort of determined that instead of a miss to the left or to the right, scoring for the opposite alliance, those wanted to just sort of bounce off and sort of ricochet back into the field of play. And so this sort of then kind of got further evolved, further refined. And at this point and through here, we're not making major changes anymore, but now we're making those refinements. And so we're narrowing in, we're zeroing in on what the final game concept is going to be. And so this sort of took us from November to February. And then in March, a lot of things in the world went sideways. And so we needed to adapt, and we needed to sort of readjust and refigure out what the plan was going to be. And so this goal that we had here in February is really, it's pretty close to the goal that was released on kickoff in September. But it's almost identical in its functionality. But we did have to sort of make some changes, change how we processed a few things, so that we could, as a business, we need to stay in business so that we can keep, things going. We need to make sure that we can do things in a way that'll keep the staff and manufacturing healthy and all that sort of thing. So we needed to start working on some of those changes. So that was a very different development cycle than we've ever had in the past. But we were, fairly excited with how that was able to go, and still try to hopefully provide a really, positive goal for everybody. And then, okay, so that's kind of the long and the short of some of the game design, game development process. So I guess following on sort of from February onward, pretty close there is when we're starting to lock in some of the major tooling. So some of these components need a lot of tooling, in order to manufacture them. And so that tooling can take several weeks, in some cases, several months to create. So we had for the game piece this year, these rings, this is created in a big 2-part steel mold. Similar, it's not quite injection molding, but it's similar. And so those tools take, that one took almost a month to create. And so once we create that tool, certain details of it are very hard to change. And so we have to be very confident when we sign off on that tooling, before it goes into production, because once it's done, if we don't like something, that can be very time consuming, very costly. Some changes can be made once the tool is made, but other changes would require starting over and making a whole new tool. So, we have design review processes. We all sort of, sit around and look at, those components, as a team here at AndyMark, and also with the GDC again, to make sure that we like what, where things are at. And then when you do that, we can commit to tooling. Usually we get samples in, from those tools, sort of in April. And then on some of the shorter lead time components, we're sort of committing on those designs April, May, and then we're sort of off to the races manufacturing those, from all across the summer, and getting those boxed up and ready to go. So that way we have them ready for kickoff, and shipping things all over the world. So that's kind of the rest of the timeline. If anybody has any questions, I don't think I've seen anything come through in chat just yet, possibly. But if anybody has any questions, here, I'll drop off screen share for a moment. If anybody has any questions, feel free to drop those in the chat, and I can take a minute to answer some of those. Yeah. One sec.
No questions for the moment.
Okay. So then we'll sort of shift back over. We can talk about some of the FTC robot, parts, sort of our ecosystem of robot parts. And I can give a little background on that. Where's my cursor? All right, so some of our history with FTC, we sort of launched our FTC specific robot parts back in, we had some early ones drop in 2014, and then we had sort of our standout, sort of big first splash, big initial, product was the Never-S motor in 2015. And so that motor, the reason it is the exact sort of way that it is, the reason, the details about that are the particular way that they are, specifically came from talking with the community, specifically, from talking with FTC teams, to see what their frustrations were, with some of the old motors, but more broadly, we just sort of asked, hey, what makes it hard to build an FTC robot? What makes it really frustrating to build an FTC robot overall? And some of the old school motors were universally sort of the thing that people pointed to, and sort of asked us to put some time and effort and resources into. And so from that point of view, we started working on a motor. Again, this was another point where we worked with first to sort of say, okay, what would be a legal motor, because we need to get that motor sort of in the rule book so that it can be utilized by teams. And so they gave us some good direction that way. And, we went out and found a motor that was going to do all of the things that we wanted to do. Chief among those being the reliability. The old motors, if you sort of, handled them the wrong way, you could, cause them to go bad. You could cause them to die in only a few seconds. And with how hard teams push their robots, being that close to the limit was very, very frustrating and expensive and time consuming to be blowing up motors that frequently and having to replace them. And so, the Never-S motor got its name because it was a motor designed specifically for reliability. We wanted to never stop working. We wanted to never rest. And so through, listening to our community, through getting that, sort of direct feedback, we were able to put out a product that really solved a lot of the issues, that they were frustrated with. And so it quickly became the gold standard of a motor in FTC. Now, kind of wonderfully, this style motor, not this exact motor, but this style motor has now been, something that a lot of the vendors, that are trying to have parts for FTC, they now have sort of a similar version to this motor, which just goes to help more and more teams get, good quality part. And so that's something that we're sort of really excited about, that now there's sort of that big point of frustration, doesn't quite exist anymore. So some of the other parts and products, that we have designed and manufacture here, so the Mecanum wheel, our 4-inch HD Mecanum wheel up at the top here. This is one of our more prolific sellers, more popular parts for FTC. We actually started designing that wheel for the FRC competition, the big robots. But so many FTC teams were buying it and having to go through a bunch of jump through a bunch of hoops to try to adapt it to work with an FTC robot, that we started with this version here, and then we changed out this center core so that it would be a more FTC specific design for, with this core here for, all of the FTC teams out there. And this has been another really, really popular product. People really love how durable these mechanical wheels are. We have one of our other innovations. We were actually the first one to do this. Is create a hub. For us, we have hubs we had an existing line of hubs. So these were sort of our new hubs or our nano hubs, or that all just kind of got condensed down into nubs. And so the nub goes through, and the thing that it did before anybody else was it had a 6mm D profile in the bore of the nub itself. Before the nub came out, everybody else just had a round through bore hub component, and it used the set screw to help sort of anchor it in place. And it was really sort of overusing that set screw. And so, those were backing out and just creating a lot of frustration. And so by really pushing hard on some of the manufacturing angles, we were able to, develop a process with one of the machine shops here in town to create that D profile in the material of the nub itself to get much better performance, much better torque transmission. And now that set screw is doing far, far less. So you're a lot less reliant on, that particular set screw. And so the issues around them backing out, are just really, really played down. Now, since then, again, a number of people have come out with D-profile, hub components, and that's something that is kind of exciting to see out there. One of the things that I'm more proud of from a product design standpoint is the tile runner chassis pictured here. This was a thing that we were able to leverage a lot of the expertise that we have around, putting together a really robust, reliable, rigid robot chassis. And, we're able to put in a lot of variation, a lot of places for customization and integration with the rest of the robot. And so that chassis really provides you a lot of space to have a really blank canvas for the whole rest of the robot. It can go from a 6-wheel drive to a Mecanum platform. We have a sort of a 6-wheel drive omni-wheel variant. We have a tread variant. If you really want to climb over a bunch of really crazy stuff. We've got all sorts of different versions now with different motors, from the Never S20 to the Never S40. And some different options, to save a little bit of cost, on sort of paring down some of the gear ratio elements. And so now our tile runner configuration page, really allows you to sort of put together the chassis package that's, really right for your application. And so one of the big features of the tile runner platform is, you can see there's a ton of holes, in the sheet metal here. All of those holes are on a 16mm sort of universal 3-dimensional grid. And so with something like our S3 tubing, these holes are, again, also on that same 16mm grid. So if I take an S3 beam and I bolt it to the top of the chassis, it's going to line up with a beam, bolted to the side of the chassis. Those are offset by 16mm. So I can then bolt those together, say higher up or something. And so one of the things that we worked really, really hard on with that chassis is making sure that no matter where you bolted on sort of the next component, things would always line up. They would always sort of be on that universal 3-dimensional grid, which makes it, really easy to sort of build things from the chassis upwards. So the S3 tube, this is our simple superstructure system. And so the S3 system was really designed to be all the structure for all of the components that sort of live from the chassis upwards, commonly referred to as the superstructure. And so what these beams allow you to do is save space on the robot, because they're much smaller than, you know, some of the bigger like C channels and some of the bigger robot components. They're sort of inherently strong, you know, because they're sort of a fully enclosed, you know, box tube sort of shape as opposed to being an open C channel. And the hole pattern that exists on here, we have sort of the slotted face, where each one of these starts and stops every 16 millimeters. And then we have sort of our dotted face. Again, these holes go all the way through the tube. And these allow you to sort of be a little bit easier, be on that 16 millimeter grid. And the large holes also, again, sort of line up with the nubs, so that if you wanted to try to turn one of these into sort of like an arm, you know, turn it into like a drive component, you know, or a moving piece, you can also do that with this system as well. The big reason for the slotted face, and this is sort of unique to the S3 system, is it gives you the freedom and flexibility to sort of put a bracket, or sort of in this case, maybe a gearbox. I can put that bracket anywhere along this rail by moving the bolts along those slots. So I can, you know, slide this gearbox all the way along this rail. And so if I slide it up and down through one set of the slot here, and I say I run to the end of where that slot is, and I want to move to, but I want to keep moving it along. Well, I can move those two bolts from those two slots down a pair, and then I can keep moving it along this face of the tube. So truly, you can put, you know, one of these components any place you want along the length of this tube. But if you find yourself that you want it in a specific spot where, you know, it'll be anchored in and sort of be on that grid profile again, then all you need to do is sort of hit the top and bottom of, you know, any two of the slots. And now, you know, again, it can't move, and it's locked into that universal grid space. So that's kind of another, you know, place where we're trying to, you know, really help allow for a lot of build freedom, you know, but still, you know, on a little bit of an easier, you know, level, by keeping sort of on that universal grid, it allows to, you know, really sort of ensure that, you know, a lot of your components are going to line up. If I have a beam running across my robots from two things that, you know, maybe have a little bit of flex to them, I know that they're supposed to line up, so I can pin that last joint in place and sort of bring everything back to, you know, my nice rigid alignment. And so the S3 beams, you know, we can get, you know, we sell these individually, you know, but we also have some large sort of building kits. And so that's sort of what, you know, this sort of picture is here. So we have those with a number of S3 bars, a number of brackets and standoffs, and a whole bunch of hardware, to really try to be like the full superstructure system for the top of the robot. And so we have those in some starter kits, and we also have those in some various bundles so that you can really get, you know, a nice, if you're looking for a ton of material, you know, we have some larger bundles so you can really get a whole bunch of material. You know, if you're looking to get a little bit of a smaller amount, you know, try things out, you know, we have those options for you as well. And then some of our more popular sort of component level parts have been our compliant wheels. So I have a few of those here. So we have sort of one of our most popular, our 4-inch green compliant wheel. You can tell these are really, really squishy. You know, teams really love using these for stuff like picking up game pieces or you know, really doing that kind of stuff. We also have a 3-inch compliant wheel. These don't interface quite as well with the bolt pattern for a nub. But on the 3-inch wheel, we only have these in 1/2-inch hex and 3/8 hex. So they, you know, it's not impossible to, you know, adapt those over, you know, but they're just kind of not quite as easy as getting, say, the 4-inch with the FTC pattern, or a 2-inch wheel with, again, that same FTC bolt pattern here, but now just in 2 holes instead of all 4 holes. The 4-inch wheel has a solid hard plastic core with then the squishy material on the outside. Our 2-inch wheel doesn't have any room for a core, and so these are just all squishy the whole way through. But because of the way that they can bolt into something like a nub, you still get really, really good performance out of these. And so these have been very, very popular. A lot of people like those. They were one of the things that were a little bit more fun for us to design and develop around here. But we also have things like our stealth wheel. And so these are hard plastic core all the way out to the rim. And then the tread material gets sort of secured on from there. And these allowed, these are really great drivetrain wheels. They allow for all sorts of different, applications. I know people are using them this year for like a game piece shooter wheel. So all sorts of different, fun stuff that way. And a lot of times on our wheels, you'll see different colors to the tread. And so across all of our wheels, that color represents how squishy the tread material is. So the scientific unit for that is the durometer. And so that sort of is a scientific measure that describes how squishy something is. And so the green wheels are the softest wheel that we have, the softest material. And so those have a durometer of 35A. So there's an A scale, a B scale, a C scale. Each one of those scales gets, progressively harder and harder. And so the A scale goes sort of 0 to 100. And so this is a 35A material. We also have a 40A material in the orange wheels. And then the blue wheels are a 50A. The black wheels are 60A. And then we have on some of our larger wheels, we have a gray tread, like the Mecanum wheels, that gray tread, that is a 75A durometer material. And so by comparison, those are rather hard. And so that kind of, maybe helps paint the picture as to, kind of the range, that those wheels sort of cover. And so, so those are some of our really popular things, some of the things that I'm, really proud of, sort of designing and developing through the FTC ecosystem, that we've got, going on. And so one of the things I wanted to sort of touch on here, do we have any questions that have filtered in?
Yes, there are a few questions in the chat.
Oh, lovely. We'll stop that. Okay, so do you choose, question coming in here. So do you choose the season theme, or does First give you the theme? So that's a great question. First gives us the theme. And so I don't know exactly how they develop that theme, that how they figure that out. But I do know that they have they've gotten a lot of really good feedback around having sort of all the programs sort of themed together. So that is a thing that I would sort of suspect will sort of continue to happen moving forward. From YouTube, how do you deal with metric / imperial parts and fasteners and sort of cross compatibility? Another really good question. So typically, we do a lot of stuff, here at AndyMark with imperial fasteners. And there's on the FRC side, which is a little bit of which is an older product line that we have, there basically everything is imperial. All of the sizes and dimensions, the hole patterns and everything like that is all in imperial inches. And so there it just kind of, everything all sort of works together nicely. On our FTC side, you guys heard me using a lot of metric for hole sizes and offsets and those sort of things. That was really done so that we could be compatible with some of the other building systems, that were sort of out there at the time when we were sort of laying the foundation for our, sort of ecosystem. And I believe actually some of those have their origins in, the little attachments that come with hobby servos, that those are on metric standards, and some of those things got carried over. So there's some weird origins to some of the stuff. We kept those because we wanted to be cross-compatible. And one of the weird parts about those is that the system that we sort of helped kind of we wanted to be compatible with, had metric spacing and English fasteners. And so that makes our FTC ecosystem very strange, that it has a mix of both of those. So really for us, the big part, we don't really try to have things that are super crossover between, English and metric English and metric as much as we can. And it's kind of just around, making sure no matter if it's an English or metric fastener, making sure that, whatever hole you're drilling or whatever you're trying to secure together, that all those holes and all those tolerances line up for the fastener that you're using, is really sort of the big thing there. The one thing that we do is we do, kind of standardize around, a particular set. So we have, typically it's like number 10 hardware for our FRC robots. We have number 6 hardware for our like FTC robots. And those standards are more or less, held to, so that makes it a little bit easier. We're only dealing with one size of fastener. All right. Another question from YouTube. How useful is having a 3D file of the project before actually working on it? I assume this is kind of talking about like a CAD kind of a question. So different people, different design teams are going to have a different answer to that question. For some processes, like for a 3D printed part, right? You need to have this entire thing at full detail in a CAD model before you can run it through a 3D printer. A 3D printer can't just make, make a part out of nothing, right? If you're, if you're doing something, you're assembling a robot, you've got a whole bunch of parts, you've got a whole bunch of S3 or some other sort of building system, and you're sort of just bolting stuff together. There you may not have a full CAD file with every nut and bolt and screw in detail, ready to go before you start building. And it really just comes down to how does your team work the best way? CAD is a tool, the same way a wrench or a screwdriver or a hammer is. It's not the only tool that you need, and it's not the best tool for every single job. So using it in conjunction with other design tools, works out really, really well. We sometimes joke, I don't have an example here, but we sometimes joke around here that, for us, CAD stands for cardboard aided design, because we will do, we'll mock something up in the real world, out of big sheets of cardboard, out of boxes, sort of setting, the size and shape of things, that way, doing it sort of proof of concept, very quickly out of cardboard. I've got a set of prototypes on what will be next year's FTC game, that have a bunch of cardboard on them. A bunch of the tower goal, the ramps and chutes were developed, that way. And so any sort of, like CAD, any sort of thing like that, those are design tools to hopefully to help you answer questions, solve questions before you're sort of doing it, the final time. And in a professional setting, when we're talking about manufacturing hundreds or thousands or tens of thousands of components, we need to, we typically need that CAD tool to sort of go through and verify, is this thing right before we go to that level of production? And so, the cost of change after, if we notice that we have a problem way down the line, is very, very expensive. On the flip side, the cost of a change for an FTC team to move a component on their robot, maybe move their arm from, you know, here to there or something, you know, that change, the cost of that change may be half an hour. Now, if you're doing one robot, that could be very, that's easy. That's a half an hour, no problem. If you're going to try to make that same change on 1,000 robots, now you have a big problem. That's something that probably should have been caught when you're doing your CAD development, you know, way before you went to production. All right, these are great questions, so keep them coming. These are fantastic. From YouTube, what would some of the biggest and most common mistakes regarding planning a new piece / mechanism, and how should you overcome them? I would say mechanism, biggest, especially on sort of the robot front, on the mechanism front, the biggest, I don't know if it's a mistake, but you know, the biggest hurdle, the biggest challenge that people kind of are trying to overcome a lot of the time is, how do I get for this right? How do I get my ring thrower to interface correctly with my floor pickup, to interface correctly with my drivetrain? That high level integration is a really tricky part of the whole thing. Getting those systems on the robot to work together really, really well is a hard thing. And so sometimes, you know, that's where, you know, a little bit of, you know, CAD to sort of try to work out, hey, this is where those handoff points are going to be. That could be a really great way to sort of figure that out. I know that there are some robotics teams that will sort of build what they call a sloppy copy of the robot. So it's just a really quick way to sort of check that all the stuff works together. And if we need to drill a zillion holes in it, you know, to get it to work out the right way, you know, then we're going to do that. And then we'll take all of the lessons learned there and we'll go sort of make a clean copy with all of those lessons learned up integrated into that clean copy, and sort of go that way to, you know, put their final robot together. So big thing that I'd look out for would be that integration piece. All right. A question from YouTube. What things can cause a change in the design of a robot? Great question. So that I would say a reprioritization of, you know, the different game tasks on the field. So if you start, you know, if you were starting to build a robot for ultimate goal and you had a robot that was really, really good at stacking rings on the wobble goal, and then you started to see maybe some other match video, or you started to realize like, hey, this is not the way that we can score the most points. You know, this is, you know, there is a, you know, there are other solutions out there. Well, you may change, you know, part of the robot to now go like have a floor pickup, you know, and a shooter into one of the tower goals, something like that. So, you know, reprioritizing, you know, different things. I'd also say, you know, like if an early prototype doesn't work as well as you want it to, you know, again, that's kind of another way in which a priority, you know, can kind of change. You know, in the beginning, your priority may have been, I want to get some sort of a game piece manipulator on the robot. You know, I don't care how good it is. I just want something that can kind of generally work. You know, and then you play with that for a little while. You get good at driving that robot for a little while, and then priorities sort of change. And you're like, actually, I would like something better on the robot. And so there you may go through and make a you know, somewhat substantial robot change in order to put a better functioning, more accurate, more, you know, reliable, you know, sort of component, you know, on the robot. So stuff like that, you know, can kind of cause big robot changes. Question from YouTube: is the S3 hole pattern compatible with Tetrix Max? I think so. I believe Tetrix Max is on. Yes. Okay. Sorry. The circular pattern on Tetrix Max is a 16 millimeter bolt circle pattern. So there is a lot of crossover. There is a lot of compatibility there. The one trick, the one sort of hang up with the Tetrix Max like C-channel hole pattern is there are some somewhat obvious places that holes are missing from that pattern. And that makes it a little bit hard to interface with those beams in any which way that you might want to interface with them, sort of in the build of your robot. So, you can't quite put things everywhere, but that hole pattern is sort of a base 16 millimeter hole pattern, at its core. So, especially the line of holes down the middle of the Tetrix Max pattern, those do line up with all of the stuff that we have on the S3 beams. So, fantastic question. Thank you. From here on the Zoom channel, we have, what material would you recommend for building game structures for teams that cannot yet afford them? Great question. So the tower goal, that really doesn't need a whole lot of structure, behind it. Really the game pieces, they're foam, they're kind of wiggly. They weigh about half an ounce. And I'm sorry, I don't know what that is in grams. But they don't weigh a lot. And so, these are not, some sort of a thing that, you need a really sort of profound structure. I know a lot of teams, that are sort of, playing remote events, playing at home. They just sort of took a, cardboard box, sort of folded it flat, and then they cut out the 3 rectangles that represent the openings of the goals, and they are just chucking game pieces all the way through, sort of that one panel of a tower goal. So, really for something like the tower goal, you're looking to make sure that your accuracy is where it needs to be, your height off the floor and your range from the goal is where it needs to be. And so, that is, you're really trying to build something that will allow you to test those things that you're most, sort of curious about. So, you really don't need a, big structure. Cardboard boxes, work great for trying to build a tower goal. The wobble goal or the rings, trying to get those, that would be a little bit trickier, to try to get one of those, without buying them from AndyMark. And so we do have those, as separate options. So that way they are, you don't have to buy a full field in order to get those components. So that is sort of a lower cost way to sort of get some of those hard to prototype, hard to one-off manufacture parts, and use and kind of use that, sort of for the best of both worlds. I hope that answers the question there. Another question from YouTube. I've seen some people on r/FTC mod, the Never-S motors, particularly the Never-S 20 gearbox, in order to get higher RPM. Is this legal? Okay. Disclaimer, I am not the rules answering committee. I'm not on said rules answering committee. So I believe that I have an understanding of the rules, but if I would definitely check with the first Q&A, on some of those sort of elements, specifically around the rules. What I can say about the rule book is the rule book really tries to govern the motor itself, not the gearbox. So more broadly, if you were to buy a Never-S 20 and a Never-S 3.7, and you were to swap those 2 gearboxes between the 2, perfectly legal. If you were to buy a Never-S motor only, and you were to put on a 4-to-1, like Never-S Sport gearbox, perfectly legal. The controlled aspect of the motor allotment for FTC is the core motor itself, not the gearbox sitting on top of it. And I think I have, yeah. Sort of to better illustrate this, when we're talking about sort of a Neverest motor, or in this case, a Neverest 20, what we're sort of talking about is the encoder, the motor, a 20-to-1 gearbox, and the output shaft. So this sort of don't quote me on the encoder. I'm not terribly sure about that part, but definitely the motor by itself, this chunk in the middle here, this is the controlled element within the rule book. And so this is the thing they have to be very careful about how you modify this. There is some specific language in the rule book about what you can and cannot modify to the motor itself. But the gearbox, to my understanding of the rules, the gearbox is totally fair game, totally open to whatever you'd want to go do. So if you want to modify one of these to make it faster, by all means, go for it. All right. These are lovely questions. Keep the questions coming. We've got lots of time to kind of keep this conversation going. Let me switch over here a little bit, and we'll talk for just a brief moment about some of the best ways to utilize the website. So I'm going to share my screen one more time. All right, so when you go to the homepage, AndyMark.com, you sort of get met with our nice banner up at the top here. Because the FRC season just kicked off this past Saturday, we've got some FRC style elements here. But we also still have all of our FTC things. We have our configurable tile runner page over here, and so there's some really nice resources up at the top of the web page up here on the header, and this is on all of our stuff. So we can go to like first tech challenge, and we get a number of good sort of robot components, and then the game components that you see sort of on the page here. And we always try to help make this landing page a really nice resource for teams. And kind of give them all sorts of different, looks at different components, and also different sort of spare parts for their game field, in case, they're looking for, a little something extra or whatever. And then this here is that remote game kit, that I kind of touched on just a moment ago, where we have a pair of wobble goals and some rings by themselves, at a lower cost than a full or a partial field even. So we've got some various tile runners and some different, motors and gearboxes and things. And then one of the other things that we do each year for the FTC game is put together some assembly videos. Now we have assembly instructions, if you're looking for, more of a paper copy, with some step-by-step instructions. But we also have these assembly videos if you'd like to, watch somebody go through it. And, if you're, maybe more of a visual learner as opposed to a tactile learner, this may be an easier way to, get that information about how to, go about the building the field. And then some of the other resources, that are here that are kind of good to touch on is we have a lot of our documentation sort of quick linked over here. So for a lot of our components, we have step files or 3D CAD files, listed, on this sort of repository all in one spot. And so to all the questions that we had earlier about, CAD programs or CAD usage, one of the biggest things I would say is don't reinvent the wheel. So in order to go through all of the mass manufacturing that we've had to go through, we've got full detailed CAD files of all of these components already. And so those are sort of listed here in this repository. And so if you're looking to build a robot that utilizes one of these game rings, then you can just go grab the CAD file for a game ring and put that into your model and be able to test and verify and check, that it works. This would be sort of a spot to like, don't don't try to redraw this shape in CAD. That CAD file already exists. And so we have a nice little search bar here, so you can go through and find on this page where some of those files might be. In addition to all the CAD files, we also have our PDF drawings, and so these are sort of all of our technical drawings. And so we have like, oh goodness. So this is one of our components from one of our shifting gearboxes. It's sort of one of our more FRC specific products. But we have the full technical drawing that went over to manufacturing for how to make this part, so that they could get all of the critical dimensions that they need and all those sort of things. And so we have a ton of these CAD these drawings up on the website, for your reference there. So all of these things are there and ready for your use. And again, search bar here to go through and help find the things that you're looking for. And we have some of our, whoopsies. Oh, we do have gift cards. But we also have a nice long listing, sort of an all-in-one repository for our assembly instructions. So that resources tab is a really nice sort of all-in-one place to get the CAD files, the technical drawings, or the assembly docs that you might be looking for. Additionally to that, the search bar functionality is really rather good. So I'm gonna maybe come over here to our tile runner configuration page. There we go. And now I have a bunch of different drop downs for how I can configure my tile runner. But more generally, all of our product pages kind of sort of look the same. You've got a picture of the thing here. Some of the high level, if there's any sort of selection or drop down, that'll all be here. And then, we have sort of product overview, maybe some specs or all sorts of different information that you might need. And the tile runner has gone through a couple different iterations, and it used to have a few options. Now it has like 200 some odd options with all of the different configurations. But if you're looking for one of those options that we used to have, we have some of the quick links to exactly that configuration in sort of the modern way. A description of what these part numbers mean is sort of this segment here. But then down at the bottom, once again, we have sort of our documentation section again. And so here specifically for the tile runner, we have our assembly guides, our layout prints, and our CAD drawings or step files. So once you're on a product page, if that's something that you're really interested in and you'd like to know more about those specific products, that information is typically down at the bottom of the page in the last section under documents. And so that's sort of another really great resource. And I guess one of the last things to sort of touch on is the search bar, and our search functionality on the website is rather good. It's actually the thing that I use to sort of navigate the website most often. And so it is a rather good search engine. So I'll use that to try to go directly to a product page, as opposed to maybe going through sort of mechanical gearbox or motor or something sort of like that. So that's sort of the system that I like utilizing the best. And then we've always got new stuff coming out, and so here if you're looking for a listing of just sort of what our most recent things are, what our new things are, we've got that stuff sort of listed out here. Some of the some of our components we've had for a little while, but we're making revisions to those. Some things are just new product that we're launching for the first time, and we're kind of all sorts of different stuff going from there. So that's kind of some of the ins and outs, kind of some of the ways to sort of get the most out of the AndyMark website. All right. So any further questions? Any other interesting things? If you want to know about more of the game design process, any of the robot components, if you have a website question, anything like that. If you want to know any more sort of background or history to some various things, we can touch on that sort of stuff. and we can kind of go in whatever direction you guys want to go.
Ce ați dori să mai aflăm de la Danny? So Danny, by now I had all the questions from YouTube.
Okay.
Well, it's one more question, which
Fantastic.
I will post it in the chat, and maybe in the meantime we'll find out if there are questions from the audience here.
Questions from the Zoom call. If you feel free to drop those in the chat room. The question that came over from YouTube is, are you ever going to make a differential swerve drive module? That is a fantastic question. Those are really, really cool devices. They're really kind of nutty, and they're a lot of fun. We do not have anything sort of in active development on that front at this point. We were kind of doing some more recent upgrades and sort of revisions on our swerve and steer module, which is a slightly more traditional swerve drive module. But that's not to say that a differential swerve, might not happen somewhere down the line. But we don't have anything right now. But I can definitely add one, add to the list of another, person sort of asking for that kind of a product. And getting that kind of customer feedback really helps to inform what projects we work on and sort of in what sequence. So, all right. So another question from the chat here. How do you settle on the size for game elements, like the size of the ring? Great question. There's a lot of different factors that go into play there. And so really it's a balancing act of all of those different factors. And so some of the factors are going to be like, how many fit in a box? When we ship big bulks of these things coming in from the original manufacturer, how many fit in a box? Is there some consideration that way? We generally are kind of thinking about, okay, how do these fit in and around a robot and the playing field? There are some times like the giant ball from Velocity Vortex, where the goal was sort of specifically that they wanted to be much bigger than the robot itself. Other times, we're looking at a ball and we're like, no, the challenge here is what they're doing with the ball, maybe not, the dealing with the size of the ball. So how much is the size of the game piece a part of the challenge for the year is definitely a thing that sort of factors in. Shipping both directions from the manufacturer to us and then us to the teams is another consideration. And sometimes it's just, once all those things kind of get sorted out, there's still some details to work through. And sometimes it just comes down to a little bit of an opinion. This looks nice. And so the size of the ring, is definitely a little bit of like, okay, this looks right. This looks nice. And then there were some features around like this vertical edge here was sort of designed in knowing that a lot of robots were going to use a wheeled shooter. And so having a nice flat section to roll against was going to help make a wheeled shooter more effective. And so that, was something that we kind of put in knowing how robots play the game. And so it's a little bit of a lot of things, but that's more true in engineering than there being sort of one definitive right answer. Engineering is really sort of the applying expertise to a lot of different trade-offs and to a lot of different optimization pathways. All right, question over from YouTube. Just other drivetrain options that are not the standard 6-wheel drive plus 4-wheel mecanum drivetrains. I guess that would be maybe a request for more drivetrains. So yeah, there's we're always kind of we've always got things sort of bouncing around. The FTC rulebook has been fairly stable in the 18-inch sizing box. So we've kind of kept most of our drivetrain development sort of around that space, and sort of kind of continue to play with some of those things. But there is a 3-wheel OmniDrive configuration that like is just sort of it's usually called a Kiwi drive or a Kilrow drive. That's been out in the world for a very long time. That's not something that we've really played with in a significant way. So maybe that is something that we can try to develop a little bit farther for you. So we'll, yeah. All right. So question from YouTube, who chooses what new robot components are added to the site? Lovely question. So that is a big team effort. So we have the engineering team that I'm a part of, and so we work with our marketing group, our customer service group, excuse me, and we get to go out to a lot of events, and we get to talk to a lot of people and sort of figure out what product people are looking for. What kind of things happen that way, and so that's sort of what starts the ball rolling. What kind of we've got a whole bunch of ideas, and all those ideas, kind of funnel through what is the customer actually asking for. And then from there, we kind of keep going, and now we start actively developing those things. And once they get to sort of and at that point, we've already had big team discussions about, is this a thing that we should pursue? So that's kind of one of the first check gates. And then we sort of move from there. We actively develop the product. We start testing things. We start making prototypes. And then, if that whole phase, goes really well, then we'll start, really trying to nail down, like, for the budget, like, yes, customers may be asking for this, but if it's $1 million, then they're still not going to buy it because it's too expensive. So we have to make sure that we are providing a good product at the right price. And so if we've got another way so once we start getting quotes in from vendors and manufacturers, and we can start really nailing down the price, again, we sort of have another big, team meeting. We have another big, like, sort of check valve to say, is this the right thing that we should do? Should we go into manufacturing? And basically, once we clear manufacturing, then it is on sort of a straight path from manufacturing to verification, and then onto the website and for sale. So there's once we hit manufacturing, then it's destined to go on the website. We wouldn't manufacture something and then not put it on the website. All right. So question from the channel chat here. How do you make sure the game you designed is safe to play? Good question. Do you also design a robot that could theoretically compete to test the game? Also, great question. Making sure things are safe to play is a lot of testing. It's a lot of sometimes destructive testing. Really sort of using and abusing the components way beyond what they will be utilized sort of out in the real world. So like last year with Skystone, we had those foundation plates on the floor, and so we knew, even accidentally, somebody's going to step on one. And so we were jumping on the prototypes that we made to make sure that they were going to be strong enough so that they could hold up, to anybody's sort of any little accident, that kind of a thing. So doing stuff like that, on if we have a trip hazard like the limbo bar last year, we see what that's going to take to sort of get pulled over, and what might happen that way. So we're doing a lot of testing, a lot of verification to see if those are safe, because it's so dynamic. The game changes so significantly year in and year out. We don't have a super specific process, but it is something that we pay a lot of attention to each and every year. And then, do we create a robot that could theoretically play the game? actually, we create a robot, or most of the time, we actually create a robot to play at least some part of the game. And so like we created a little, robot to throw the rings around to see how far a robot could throw a ring, or what that might look like, to make sure that it was sort of within the realm of possibility. We don't want to go all the way through and like solve the challenge at a really high level, but we want to verify, is this possible? If given the motors or the size or the things that were capable, and legal within the FTC rulebook, if there was something that was just like flat out impossible, the laws of physics dictate that you can't do this with that much power in this amount of time, then we'd have to sort of go back and rediscuss that and figure a better way to do that part of the challenge. So like our robot never had a floor pickup. We just sort of fed it in by hand, but we were able to validate, you can throw one of these across the field and have it be okay. Touching on the safety angle for a minute, we were like, okay, like how much does one of these hurt? So we had a few volunteers and we, turned our robot all the way up as high as it would go, and we shot people with the rings and it didn't hurt all that bad. And so we're like, okay, like this is something that we like. We only need netting on one end of the field, and in the unlikely event that somebody gets hit with a ring, it won't hurt. They're squishy, lightweight foam, so we're pretty confident in that. And so so we're playing through and evaluating a bunch of those. Actually, about a month ago, we were sort of reviewing some really old files from one of the really old games. And at that point, we were trying to evaluate, it was Velocity Vortex again. We were evaluating if a robot scoring in the low goal could outpace a robot scoring in the high goal. The lineup is a lot easier going into the low goal. So, you can kind of get with, the idea that you can score in much higher volume. You can score at a faster rate in the low goal, but they're worth fewer points. And so we are trying to help first in the game design committee nail down how big that difference should be. And so like partway through the summer, I think it was like June, July, something like that, we had two robots built, that one was scoring in the low goal and one was scoring in the high goal. And we played 2-minute matches, and we were driving back and forth. And so we found some of those old videos of us really sort of actually going through and playing the game, not just verifying the mechanisms work, but playing the game. All right, and then we have another question here from the chat. These are fantastic, everybody, so keep them coming. What do you consider when developing new components? Lovely question. The big thing that we try to work on is, again, making sure that we are solving the right need from the teams. We really want to make sure that our components are going to be endlessly crossover compatible with all of the other components that we've manufactured, that we sort of have in the AndyMark ecosystem. And we want them to be reliable. We want them to be robust. The AndyMark sort of as a design group, as sort of a philosophy, we really sort of hone in on making things robust and reliable. There are other vendors who are really looking to push sort of that high level performance. And so they may go with a lighter weight component because you can get a little bit more performance out of it. And you're running it a little bit closer to its threshold. And for some people, that's what they're looking for. The AndyMark sort of philosophy has sort of always been to sort of be that sort of reliable, component. That means they're a little bit bigger, they might be a little bit heavier, but we really want to make sure that stuff's going to last and survive. And so that's some of the major things that we're considering. Customer first. Is it compatible? Is it reliable? All right, question here from the chat room. How many products do you end up manufacturing and how many do you give up on? Okay, in what phase do most of the products fail? That's a really interesting question. We have, I would say that we probably, I'd say 10 to 20% of all of the ideas make it onto the website for sale. It's new ideas happen all the time. And things are always getting sort of reshuffled and reprioritized. And so it is, the idea is sometimes is kind of far and away the easy part of the thing. It's, oh, I want to make a new macadam wheel for FTC. Awesome, simple idea, really clear. Now, how do we go do that, right? So that next phase is usually a little bit tricky. And there's a lot of ideas that just sort of, never really get worked on. From a management standpoint, we prioritize them, a little bit farther down the list. It's, yeah, if we could get to this, that'd be fantastic, but we're just not quite there. And so, so a lot of them sort of just stay in that idea world. Of the ones that sort of make it out of the idea and actually get sort of active development, I'd say most of them, maybe 75% of them, actually go into production. We're a little bit, sort of hesitant. We're a little particular about which products sort of get pulled down from the idea space and sort of actually start the development process. And so that means that we have a fairly high hit rate on things that we work on that actually go into production. And so I think at some larger companies that have a little bit more process sort of involved, they'd have more check gates, and so they'd have more at more of those stages. They could see our things sort of filtering out, not going into production. But for us, we really sort of have only a couple check valves, where things sort of might end their journey, or their journey gets put on pause. And so when we pull something down out of the idea space, we really try to, it's very likely that it actually goes into production. So fantastic questions, everybody. These are awesome. So if we don't have any other questions come through, those sort of the last of the kind of sections that I had prepared.
So if no more questions, we'll resume the session here, and hope to have Danny again. Maybe you'll have to test your robots on the field, as the competitions will soon be started.
Cool.
The demo ones, at least, and the official ones, April, May, June. I will announce the calendar soon. So thank you, Danny, so much. You had quite interesting questions. I know the students and the mentors appreciate very much the AndyMark products, are quite reliable and robust, and hope to have soon in Romania a spare part warehouse. So we are in discussion with AndyMark to bring here and to help Romanian teams, and not only teams from Europe, to have an easy way of ordering AndyMark products.
Very cool. This has been absolutely wonderful. Thank you everybody for having me on tonight. This is wonderful. I really enjoyed it. The questions, the discussions were really great. And I wish everybody the very best of luck with the season this year. I hope you guys, I hope the robots do great, but more importantly, I hope you all learn a lot and have a lot of fun.
Thank you. Mulțumim. Seară bună. Pe curând. La revedere.